A random sample of male systolic blood pressure values is given below. Generate the normal quantile plot for this data set and determine whether or not the data come from a normally distributed population. Okay, so first we want to create the normal quantile plot. Now a normal quantile plot or normal probability plot is a graph of points x, y where each x value is from the original set of sample data, and each y value is the corresponding z-score that is a quantile value expected from the standard normal distribution. So if the points on the normal quantile plot do not lie close to a straight line, or if the points exhibit some systematic pattern that is not a straight line pattern, then the data appear to come from a population that does not have a normal distribution. So if the pattern of the points is reasonably close to a straight line, then the data appear to come from a population that has a normal distribution. So the first thing we're going to do is we're going to go ahead and click on the data, and then we're going to open the data up into StatCrunch. So here's our data. What we want to do is we want to be able to create a normal quantile plot. So we're going to go to Graph, scroll all the way down to where it says QQ plot. Okay, and then what we want to do is we want to change this column's name because these are the x values. So we're going to highlight it, call it x value. And now let's go ahead and then go to Graph, select QQ plot, and then we're going to select x value. Okay, now we want the normal quantiles to be on the y-axis. So we're going to select this option so the x values are going to be on the x-axis. So let's go ahead and select Compute. So now we have our graph. So there is our graph. And so this represents our data. Okay, so now let's compare them to the graphs that we have below. So the first one you're going to see here is the data. So you can see, let's match that, see if that corresponds to that graph. So you can see here we have these values down here. There's 0. So it doesn't look like it matches with the first one, A. Let's take a look at B. Okay, if we take a look at B, it does not look like it matches B. Let's take a look at graph C. So here's graph C, and again we can see that there's data points below here, and this doesn't look like it matches C. And let's take a look at D and see if this matches. So if we take a look at D and compare that with this one, it looks like it is slightly similar. Okay, now you see how it goes all the way down to -3? What we can do is we can go to our options, or actually not options, we can come down here and then select y-axis. So we can say that the minimum is going to be -3 and make the maximum +3 and see if it matches better. So here, if we take a look at the data here, this looks like we need to go back and take a look at the other graphs because it looks like it could be this data here. So you can see there's those 2 points, that. So that looks like it matches there. Okay, again, there should be points below here. So it looks like it's going to be D. And there is our result. Okay, now it says, do the data appear to come from a normally distributed population? Now remember that the population distribution is normal if the pattern of the points on the normal quantile plot is reasonably close to a straight line, and the points do not show some systematic pattern that is not a straight line pattern. And the population distribution is not normal if the points do not lie reasonably close to a straight line, or the points show some systematic pattern that is not a straight line pattern. So if we take a look at this graph, okay, it looks like we have some sort of points that are kind of around the line. So we can say that, yes, it does appear to be a normally distributed population, but now we need to determine which one it is, A or D. Well, A says because the pattern of points in normal quantile plot is reasonably close to a straight line, or we'd say yes, but the points in the normal quantile plot do not lie reasonably close to a straight line or show a systematic pattern that is a straight line pattern. So which one does this look like? It looks like it could be A. And therefore there is our result.